All right, so I wanted to go back to 307, solving by completing the square, because we had touched on this when we were together in person. So I wanted to go over to example 10 on the 307 guided practice. So you're going to go back and you're going to complete these. These are factoring, so practice factoring, solve by taking square roots. I'm going to skip down to number 10, 11, and 12. Let's do some practice on completing the square, because then you still have to do some mixed practice on 309. So you're going to get a chance on 309 to solve by completing the square. So I'm going to do these few problems with you on 307. So I'm going to do 10, 11, and 12 with you, and then you can finish 1 through 9 to submit this page. So when you're solving by completing the square, we've got that picture in our head, those of you who took notes on 307 already, on what it means to solve by completing the square. So when I solve by completing the square, my first step is I want to clear out my c value to the other side. So I would have x squared plus 14x equals positive 3. I add 3 to the other side of the equation. Now I need to complete this to make it a perfect square trinomial. So the formula that we learned is you're going to take half of this value, which would be 7, and square that number. So I need to add 49 to both sides of the equation to keep it balanced. And now I have just forced this to be a perfect square trinomial. So the factors of 49 that add up to 14 happen to be 7. So a perfect square trinomial is just factored into the same binomial twice. So this is x plus 7 squared equals 52. So now I'm actually solving by square roots. So this is a good strategy to review. When you solve by square roots, you get everything on one side and the square on the other side, and you take the square root of both sides of the equation. When you take the square root, this cancels the squared symbol. So now you just have x plus 7. And on this side of the equation, you write plus or minus, and you put this into reduced radical form. So would you agree that 52 is the square root of 4 times the square root of 13, I think, right? What's 4 times 13? 52, right? Okay. So if it is the square root of 4, I can write that as 2 square roots of 13. So my final answer for x is I'm going to subtract 7 to the other side. So I've got plus or minus 2 root 13 minus 7. Or if you want to put 7 in the front, you could do that. So here's my solution to number 10. I'm going to leave you number 11, I think, actually, to try on your own. But I'd like you to take a look at 12 with me, sorry. So the rule for if you are starting with a 2 here or a number that's bigger than 1, you want to start by dividing through by that number first. So I really have x squared plus 10x minus 1 equals 0. So now I'm on the level playing field of what I got over here. I'm going to add 1 to the other side. X squared plus 10x equals 1. How am I going to complete the square? I'm going to cut this number in half. So I'd have 5. Squared is 25. I'm going to add 25 to both sides of the equation. This is now a perfect square trinomial. X plus 5 squared equals 26. Take the square root of both sides and you get x plus 5 equals plus or minus the square root of 26. The square root of 26 is a reduced radical. There's no factors of 4 or 9 that could reduce it. So my final answer, plus or minus the square root of 26 minus 5. So you're going to go back and complete 307, the guided practice, and submit it. There was one more problem that we didn't do on the previous page. So how do you convert standard form into vertex form? We've already learned a strategy for this. Find the vertex first using negative b over 2a. But I'm going to show you a completing the square strategy just so you know what it is. So you are going to use a similar strategy to what we just did. And that was moving the c value to the other side of the equation. This is a y equals equation this time. I'm really just converting this into vertex form. So I'm leaving it as positive 10. I'm just kind of leaving myself room right here to complete the square. Negative 10, half of that is negative 5. When I square that, I'm going to get 25. I just added 25 to this equation. I don't want to subtract 25 over here. I want to adjust this side of the equation, so it's kind of like I added 0. So because I'm on the same side of the equation, I'm going to add 25 and subtract 25 on the same side of the equation. Up here, I was adding 9 to both sides of the equation. So when you're on one side of the equation, you want your net change to be 0. 25 and negative 25 adds up to 0. So in vertex form, this would be x minus 5 squared minus 15. If you don't like that strategy, you can do it the same way that we did in the previous unit. Do negative b over 2a, find your x value, find your y value. Let's just do one more together. This one's a little bit more challenging because of the 2 in front of the x squared, but it's most like what you'll see in pre-calculus for the conics unit. What you're going to do is factor out a 2. Okay, so what I've done is I've moved the negative 1 over a little bit, and I've done greatest common factor on the first two terms, right? 2x squared, 4x. I'm going to complete the square right here by adding 1, right? Because half of 2 squared is 1. Inside this parenthesis, I just added 1. But because of the distributive property, I really had a net change of positive 2 in this section. So I need a net change of negative 2 so that my net change is 0. So this part is going to be y equals 2 times x plus 1 squared. And this part is going to be minus 3. So if you did negative b over 2a, you would get negative 1 common negative 3 as your vertex, which you can see in vertex form. So again, you can just resort to that old method, or if you like the new method with completing the square, you have that method. Over here, it doesn't ask you to do that method at all. Just solve by factoring, solve by square roots, solve by completing the square, and then you can submit 307 as completed.